An alloy is a mixture or metallic solid solution composed of two or more elements. Complete solid solution alloys give single solid phase microstructure, while partial solutions give two or more phases that may or may not be homogeneous in distribution. Depending on thermal history, alloys usually have different properties from those of the component elements. Alloy constituents are usually measured by mass. Alloys are usually classified as substitutional or interstitial alloys, depending on the atomic arrangement that forms the alloy. They can be further classified as homogeneous, consisting of a single phase; heterogeneous, consisting of two or more phases; or intermetallic, where there is no distinct boundary between phases. Alloying a metal is done by combining it with one or more other metals or non-metals that often enhance its properties. For example, steel is stronger than iron, its primary element. The physical properties, such as density, reactivity, Young's modulus, and electrical and thermal conductivity of an alloy may not differ greatly from those of its elements, but engineering properties such as tensile strength and shear strength may be substantially different from those of the constituent materials. This is sometimes the result of the sizes of the atoms in the alloy, because larger atoms exert a compressive force on neighboring atoms, and smaller atoms exert a tensile force on their neighbors, helping the alloy resist deformation. Sometimes alloys may exhibit marked differences in behavior even when small amounts of one element occur. For example, impurities in semiconducting ferromagnetic alloys lead to different properties, as first predicted by White, Hogan, Sol, Tianabri and Nakamura. Some alloys are made by melting and mixing two or more metals. Bronze, an alloy of copper and tin, was the first alloy discovered during the prehistoric period now known as the Bronze Age. It was harder than pure copper and originally used to make tools and weapons, but was later superseded by metals and alloys with better properties. In later times bronze has been used for ornaments, bells, statues, and bearings. Brass is an alloy made from copper and zinc. Unlike pure metals, most alloys do not have a single melting point, but a melting range in which the material is a mixture of solid and liquid phases. The temperature at which melting begins is called the solidus, and the temperature when melting is just complete is called the liquidus. However, for most alloys there is a particular proportion of constituents in rare cases to the eutectic mixture which gives the alloy a unique melting point. The use of alloys by humans started with the use of meteoric iron, a naturally occurring alloy of nickel and iron. As no metallurgic processes were used to separate iron from nickel, the alloy was used as it was. Meteoric iron could be forged from a red heat to make objects such as tools, weapons, and nails. In many cultures it was shaped by cold hammering into knives and arrowheads. They were often used as anvils. Meteoric iron was very rare and valuable, and difficult for ancient people to work. Iron is usually found as iron ore on Earth, except for one deposit of native iron in Greenland, which was used by the Inuit people. Native copper, however, was found worldwide, along with silver, gold and platinum, which were also used to make tools, jewelry, and other objects since Neolithic times. Copper was the hardest of these metals, and the most widely distributed. It became one of the most important metals to the ancients. Eventually, humans learned to smelt metals such as copper and tin from ore, and, around 2500 BC, began alloying the two metals to form bronze, which is much harder than its ingredients. Tin was rare, however, being found mostly in Great Britain. In the Middle East, people began alloying copper with zinc to form brass. Ancient civilizations took into account the mixture and the various properties it produced, such as hardness, toughness and melting point, under various conditions of temperature and work hardening, developing much of the information contained in modern alloy constitution diagrams. The first known smelting of iron began in Anatolia, around 1800 BC. Called the bloomery process, it produced very soft but ductile wrought iron, and, by 800 BC, the technology had spread to Europe. Pig iron, a very hard but brittle alloy of iron and carbon, was being produced in China as early as 1200 BC, but did not arrive in Europe until the Middle Ages. These metals found little practical use until the introduction of crucible steel around 300 BC. These steels were of poor quality, and the introduction of pattern welding, around the 1st century AD, sought to balance the extreme properties of the alloys by laminating them, to create a tougher metal. Mercury had been smelted from cinnabar for thousands of years. Mercury dissolves many metals, such as gold, silver, and tin, to form amalgams and alloy in a soft paste, or liquid form at ambient temperature. Amalgams have been used since 200 BC in China for plating objects with precious metals, called gilding, such as armor and mirrors. The ancient Romans often used mercury-tinned amalgams for gilding their armor. The amalgam was applied as a paste and then heated until the mercury vaporized, leaving the gold, silver, or tin behind. Mercury was often used in mining, to extract precious metals like gold and silver from their ores. Many ancient civilizations alloyed metals for purely aesthetic purposes. In ancient Egypt and Mycenae, gold was often alloyed with copper to produce red gold, or iron to produce a bright burgundy gold. Silver was often found alloyed with gold. These metals were also used to strengthen each other, for more practical purposes. Quite often, precious metals were alloyed with less valuable substances as a means to deceive buyers. Around 250 BC, Archimedes was commissioned by the king to find a way to check the purity of the gold in a crown. leading to the famous bathhouse shouting of "Eureka!" upon the discovery of Archimedes' principle. While the use of iron started to become more widespread around 1200 BC, mainly because of interruptions in the trade routes for tin, the metal is much softer than bronze. However, very small amounts of steel, an alloy of iron and around 1% carbon was always a byproduct of the bloomery process. The ability to modify the hardness of steel by heat treatment had been known since 1100 BC, and the rare material was valued for use in tool and weapon making. Because the ancients could not produce temperatures high enough to melt iron fully, the production of steel in decent quantities did not occur until the introduction of blistered steel during the Middle Ages. This method introduced carbon by heating wrought iron in charcoal for long periods of time, but the penetration of carbon was not very deep, so the alloy was not homogeneous. In 1740, Benjamin Huntsman began melting blistered steel in a crucible to even out the carbon content, creating the first process for the mass production of tool steel. Huntsman's process was used for manufacturing tool steel until the early 1900s. With the introduction of the blast furnace to Europe in the Middle Ages, pig iron was able to be produced in much higher volumes than wrought iron. Because pig iron could be melted, people began to develop processes of reducing the carbon in the liquid pig iron to create steel. Puddling was introduced during the 1700s, where molten pig iron was stirred while exposed to the air, to remove the carbon by oxidation. In 1858, Sir Henry Bessemer developed a process of steel making by blowing hot air through liquid pig iron to reduce the carbon content. The Bessemer process was able to produce the first large-scale manufacture of steel. Once the Bessemer process began to gain widespread use, other alloys of steel began to follow, such as mangalloy, an alloy of steel and manganese, which exhibits extreme hardness and toughness. In 1906, precipitation hardening alloys were discovered by Alfred Wilm. Precipitation hardening alloys, such as certain alloys of aluminum, titanium, and copper, are heat-treatable alloys that soften when quenched, cooled quickly and then harden over time. After quenching the ternary alloy of aluminum, copper, and magnesium, Wilm discovered that the alloy increased in hardness when left to age at room temperature. Although an explanation for the phenomenon was not provided until 1919, duralumin was one of the first age-hardening alloys to be used, and was soon followed by many others. These alloys became widely used in many forms of industry, including the construction of modern aircraft,